got 8.9 notes, AP Calculus AB. All right, here we go. So they're going to graph. This is the graph of the square root of sine x. What they're going to do, okay? They're going to create a really weird shape, really weird 3D shape. They're going to take. I want you to imagine just this part, right? So ignore all this, ignore all that. Okay. What they're going to do, they're going to take this little hump here. Okay. They're going to rotate it around 180 degrees, and that's going to be your shape. Okay, so let me see if I can construct that on my app.
Because of what it said.
Because what?
Oh, I didn't say it.
We're using word one. Yes, let me pull this up. Okay, I'm getting rid of that too. So that should be the one. There we go. Sine x, the square root of sine x in a very roundabout way because this app stinks. And intervals from 0 to pi, -0 to pi because this app stinks. Axis of rotation is y equals 0, -0. Number of intervals, let's make that 150. Let's do 1 now. There you go. So we're taking this function here, okay, and we're rotating it around. You guys see that? So it's a little football looking thingy, okay? A little football looking thingy. That makes sense? Okay. Now, so this is not the bottom. This is just like half of a cross. If you cut the football in half, and you just looked at the top half, it'd be that. Okay. Any idea how we're gonna find the volume of that? It's actually not too bad. It'll make sense once I say it. But I'm leaving you in suspense right now. I'm just dangling it. Triangle? No. So I want you guys to think of this shape. I want you guys, so they rotated it around 360 degrees, right? They took this little cross section, they rotated around 360 degrees, it made this little football thing. Right? You see that? Okay. I want you to think of this shape. What else has 360 degrees in it? A circle. I want you to think of it as a bunch of circles stacked on top of each other, stacked next to each other. Okay? So we're going to find the volume of this surface by finding the area of each circle and adding up all the areas. Okay? All right, so we've got a bunch of circles, right? Okay, what's the radius of each circle going to be? It's going to be the function value, right? So if this is like a cross section of the football, right? Each circle is going this way, they're stacked this way, okay? Then the radius of each circle is just going to be from the midpoint of each circle to the top. That makes sense? So the value for the radius at each circle is going to be the function. R is going to be f of x, which is the square root of sine x. Okay? Okay, what's the area of each circle going to be? It's going to be pi r squared, right? What's pi r squared here? Pi times sine x. Pi sine x. Pi psi. That's like a frat, isn't it? Or sorority or something. Pi psi. Okay. Right, and then we're going to get the volume. We're going to integrate all those areas from x equals 0 to x equals pi. Questions, comments, concerns? You see how that works? So you're finding the area of a bunch of circles and adding all the areas up.
Wait, the R is what?
Radius. Right?
That would be
What? Volume. Yeah, sorry, it's a terrible video. It's actually gamma.
Do we always use circles with this?
Disk method, yeah, it's always disks. So, yeah. All right, any questions? Kind of weird, right? This is a big football thingy here, right? It's a bunch of circles stacked on top of each other. And the radius, right, from the middle to the top, that's the function, okay? What is this integral? This is pi times the integral from 0 to pi of sine x. pi times, what's the antiderivative of sine? Is it negative cosine? It's negative pi times negative cosine x, evaluated from 0 to pi, which is pi times negative cosine pi minus, so plus cosine of 0, which is pi times, what's the cosine of pi? Negative 1. 1 plus 1, which is 2 pi. Yeah. Okay. Let me make sure they can see it on camera. Questions, comments, concerns? All right, so on the SAT. Okay, that's not the SAT.
You just multiply by cosine, so
Where did I, how did I get?
sorry, no, you're multiplying
Can I move on to the second one? All right, integrating with respect to y, two integral case. Find the volume of the solid form by our volume region K. So we have a region, it's bounded by y equals x squared plus 1. Looks like that. Okay. Y equals 0. Okay. X equals 0. And x equals 1. Okay. So we're going to take that region, but we're going to revolve it. It's a little tougher. We're going to revolve it around the y-axis. So we've got the x-axis, we've got the y-axis. Okay. We're going to take that region. Okay. This would be easy money if we revolved it this way, coming out of the TV, like that. We're not doing it. We're doing it this way. Kind of weird, huh? Okay. So I'm pretty sure, I want to make sure I'm going to do it correctly. I'm pretty sure I know what to do. Yeah. So what we're going to do, best way to do this is to split it up. Best way to do this is to split it up. Okay. So we're going to do these two of these separately. Okay, we're going to do, let's split it up into the green region here. That's going to be trivial. We're going to split it up into the, let's call this the pink region. This is not trivial. All right. So the volume of the green region, so this is going to be what? The green region, when we revolve it around the y-axis, we're going to get what shape? A cylinder. Yeah, that'll be a cylinder. Are we having trouble seeing that? Let me see if I can get this pulled up on the app. All right. Maybe the axis of rotation would be x equals c. All right. I don't know how to do axis of rotation around y. So sorry about that. What happened? We're going to take this green square and spin it around 360 degrees. So it's going to create a cylinder. Okay. It's going to create a cylinder. Okay, the radius of the cylinder is going to be 1, the height's going to be 1, okay? So the volume of the green region is going to be pi r squared h, or just pi times 1 squared times 1, which is pi. So that's going to be the volume of the green region. Okay. All right, now we're going to do the pink region. Okay. Okay. Pink region. Here's going to be here's the strategy we're going to use. Okay. So we've got the pink region. Okay, I'm going to stretch this graph out. Okay. Pink region looks like this. If we swing it all the way around, it's going to be like swinging these two pink regions around 360. You're going to get a little bowl shape thing, okay? So what we're going to do, what I'm going to do here is I'm going to treat this, I'm going to find the volume of this whole thing. I'm going to find the volume of this whole thing, this whole orange and pink region, and then I'm going to scoop out the orange stuff. That'll leave me with the volume of the pink region. Does that make sense? Okay. So the volume of that whole thing, that'll also be just pi, right? The volume of the whole pink region is going to be pi. We have to subtract something from that. We got to subtract the volume of the orange region, right? Okay. So now this figure right here, this figure is a bunch of circles stacked not side by side this time, but it's going to be a bunch of circles stacked on top of each other. Okay? Since the circles are stacked going up to go from one circle to the next, which variable is changing as I go up? Y, right? The widths of all the circles, they go in the y direction. Okay? So now I need to do an integral with respect to y. dy. It's going to be from y equals what to what? Where's the bottom of that orange region? 1 to 2. Okay, this is a little different. Okay. When the circles are stacked side by side, I integrate in the x direction, but I've got to integrate in the y direction because the circles are stacked on top of each other. Okay. All right. So what's my function going to be then that I'm going to integrate? I need it to be a function of y. So this is the line what? Y equals x squared plus 1. Okay. How do I make that a function of y? Of y. So I have. How do I change this so I can plug in something that involves y in here? Yeah, I'm going to do y minus 1 square root of that equals x. Right? So it's going to be square root of y minus 1. Okay. So let's do this integral real quick. This is a u sub. Oh shoot, I'm doing something wrong. Sorry. So sorry. What I gotta do, that's gonna be the radius. The radius is gonna be, this is gonna be my radius. So I need to integrate pi r squared. So it needs to be pi times y minus 1. Sorry. You guys see the mistake I made? Dang it. Oh, it's going so well too. So crisp. The function is going to be our radius. So sorry. Okay. Radius of each circle. Right here, all my circles stacked on top of each other. The radius is the midpoint to the side, to the edge, right? So that function, x equals square root of y minus 1, that's going to be my radius. Right, the distance from the y-axis to the graph. Making sense? Okay. Okay, so that's going to be my radius. Square it, multiply by pi. That's the correct integral. Sorry about that. It's not a u sub. You could do a u sub if you like unnecessary work. Okay. So then it's pi times 1/2 y squared minus y from y equals 1 to 2, which is pi times 1/2 times 2 squared minus 2 minus 1/2 times 1 squared plus 1, which is pi times 2 minus 2 minus 1/2 plus 1, which is pi over 2. Okay. Questions? I did that super fast. That was horrible. That was not good teaching. So where did we get slowed down? Where are we stuck? We're not stuck? We're getting the area of the orange region, yeah? The area of the whole thing, this whole cylinder up here was just pi, right? Okay, so we're going to take this whole thing, this whole cylinder, the pink and the orange, we're going to subtract the orange from it, okay? So the area of the orange is pi over 2. Okay, so the volume of that whole top half, that just the pink region, yeah.
So if it's both sides, then would it be 2 pi, or are we only doing the right side?
What?
If it's both, because green region was pi, but if we do both squares, then would it be 2 pi?
It would have been 2 pi.
But we're only doing the right side.
So the volume of the green region, that was just a cylinder. So that volume was pi, right? That gave me pi. Okay, we're on the same page. Okay, I needed to find the volume of this top half then. Okay, to find that volume, I did the whole thing. Well, the whole thing was pi. So by that I mean I did the orange and the pink, and I subtracted from that the volume of the orange, which was what? Pi over 2. Okay, so that just gives you pi over 2 then. Okay, so the volume of that bottom half plus the top half is 3 pi over 2. Sweet, that's the answer. So my final answer is the red plus the green. Okay, so I split it up into 2. I just rotated the bottom half, found that volume. That was just a cylinder with volume pi. It is like 90 degrees in here. I swear, it is terrible. I'll put in a maintenance request. This is ridiculous. Not that it's anyone's fault. It's just not conducive to. It's on YouTube. What? It's not cute. And then this top half right here. Right, I found the volume of just the pink part. So I did the whole top half as one cylinder, and then scooped out the orange. Any questions how I did that?
Then you add pi over 2 plus pi.
Right here.
What's the final?
Final answer is pi plus pi over 2. And that gave me 3 pi over 2. Okay? So I think it's tough for students to start switching variables up. We have to do this as a function of y. Right? And that's because our circles were stacked on top of each other to integrate. To move from one circle to the next, we have to go up and down. So we have to integrate with respect to y. Because y goes up and down. Okay. S goes left and right. Can I move on to the next one? Oh, okay. Now this is 810 we're getting into. Okay, so we'll see how far we can get. I don't think this is much harder. Find the volume of the side by bounded by the graphs 2 minus x squared, so that's this. That'd be tough. Sorry about the temperature. What? They're all good.
We like choose a smooth bed.
Choose a what?
Choose one smooth bed.
Like you know, like the highest person gets 100. Someone gets 100 on all of them.
If one person gets 100, then we all get 100. Like,
One person gets 100, we all get 100. That's cool. G of x equals 1.
wait, are they
No. Oh, g of x equals 1. Okay, so what's going to happen here is, here's the line g of x equals 1. Ooh, the physicist in me wants to teach this differently. Okay, so we want to find what's going to happen is, and notice, they're revolving it about what? They're not revolving it about an axis. What are they revolving it about? So that it actually makes the problem easier. This would actually be kind of tough to do. If they revolve. Actually, it wouldn't be too bad. Anyway, let's. So they're revolving it around this line. So it's the same. It's literally almost identical to that other problem. So they're doing. Do you guys like this or no? Is this helpful or not?
Yes.
Okay. Can do this one. What's the function? X squared plus 2? 2 minus x squared? Interval is, what is that interval? Is that negative 1 to 1? What? No.
I think you squared the whole
I make a mistake.
2 minus x.
Oh, thank you. There we go. Thank you. Okay, so now it's like this. Woo, look at that. A little spinny top. Okay. Do you guys see again? It's a bunch of circles stacked on top of each other. You guys seeing that? Okay. So what's the radius of each circle going to be?
2 minus x.
Yeah, it's going to be the distance from 1 to 2 minus x squared. Okay? So the height, the radius of each circle. The radius of each circle is 2 minus x squared minus 1, which is 1 minus x squared. So that's the radius. Okay. This time, am I circle stacked side by side or top to bottom? Side by side. See that? So my integral is going to be with respect to dx. Okay. Why is that good news? We don't have to like fiddle around with the function at all. Okay. So my areas are going to be pi r squared, which is just pi times 1 minus x squared squared. Okay, so my integral is going to be from, what was that, x equals negative 1 to x equals 1 of pi times 1 minus x squared squared. Questions, comments, concerns on how I got that? So that's the setup. We just have to evaluate that integral now. We got the right answer. You having trouble? Stuff's tough. I don't know. Do you guys think this is harder than tree identities?
No.
No.
I don't know either.
Forget any of these?
Yeah, I didn't really. Where'd you get the negative one?
That?
Where'd you get the negative one?
Yeah, so you see this shaded region here, Ava? Right, here's like the little end of the pointy thing, the pointy football thing. Here's the other end. The farthest to the left we go is -1. The farthest to the right we go is x equals 1.
Can you explain anything about
The radius, okay? So this surface is made by taking this pink region and revolving it around this dashed line to create like a little onion pointy football thing, right? So the radius, right? There's a bunch of circles. This is a bunch of circles stacked side by side. Okay, the whole region is like right here. There's a bunch of circles. Okay, you see how it's a bunch of circles stacked side by side?
So it's, you go up and down when it's around the y-axis?
When you revolve around the y-axis, or like a line like x equals 1, then the circles are stacked on top of each other.
Okay.
Here they're stacked side by side.
I didn't know there's stuff.
So I'm just seeing it. The best way to explain it, you can see it in this figure too. If I make the number of intervals smaller, maybe like 100. Okay. So make that like 50. Okay. So you see, are you able to?
Yeah, I see.
Okay. So like,
But how do you know, like,
how do I know?
when to do, like,
Yeah, a lot of it's an intuition you kind of get. Terrible answer, I know. If you look at the figure, right, so when we're rotating it around y equals a horizontal the axis of rotation is horizontal, they're going to be side by side. If they were if the axis of rotation was vertical, they're going to be up and down. Okay. So the axis of rotation is side by side, and you can see in the picture too.
Why is there a pi on
A pi on the integral. So here's my radius, 1 minus x squared, right? I need to find the area of each circle and then add all the areas up. Area is pi r squared. Yeah, so let's do this integral together. Pi times integral from -1 to 1 of, what is that? 1 minus 2x squared plus x to the 4th dx. Okay, that's pi times x minus 2/3 x cubed plus 1/5 x to the 5th. X equals -1 to 1. Okay, that's an odd function, right? I won't do that. I won't do that nonsense. I know a little trick. Oh shoot. Yeah, I'm doing something wrong. So sorry. So we were eyeballing it, right? For these two intersection points. Okay, I should have drawn the graph better. Okay, this does not intersect at -1 and 1. Does it? Maybe the notes are wrong. Okay.
Should be.
He's integrating from -√2 to √2. 2 minus x squared equals 1 when x squared equals 1.
Yeah.
When x equals -1 or 1.
Yeah. I think that's
Okay, I think the answer key is wrong maybe? I don't know. Will this give me a negative result though? I don't want to do this. I'm going to calculate this in my calculator real quick. That's going to give me, I think this is going to give me 0 though. Because that's an odd, oh, that's not, I'm sorry, never mind, sorry. We're on the right page. I wasn't doing anything wrong. Answer key's wrong, sorry. Pi times 1 minus 2/3, 1 cubed, plus 1/5, 1/5, minus -1, minus 2/3, -1 cubed, plus 1/5, is -1 cubed. Okay, pi times all of that. Pi times 1 minus 2/3 plus 1/5. That's plus 1. That's plus 2/3. That's that. This becomes a minus 1/5, but then a plus 1/5. Right. That becomes.
Wait.
Sorry,
What
this
if
is 5.
the second 2/3 also be a minus?
This would be a minus 1, which makes it a plus 2/3, which makes it a minus 2/3. Thank you. There we go. That's for a function, right? Let's just leave it like that. And we're now moving on to the washer method today. So let's spend the last 5 minutes talking about this. Where are we really confused? Are we panicking? You guys, so this is a really long homework.
If I'm really
It's
long.
8-9 through 8-12.
Oh.
But do you want me to give it to you? Because like, here, I'll give it to you now. Take a look at it. It has you the disk method for a bunch of integrals. If you guys want to get a head start on it, but I won't like make you do it. Does that make sense? So yeah, this is tough. This is tough stuff. Sorry about that hiccup at the end there. I looked at the answer key and I was like, what did I do wrong? I think the answer key is wrong.